Every engineering organization eventually reaches the same conclusion. We need better observability. So they add logging, metrics, tracing, dashboards. And for a few weeks, everything feels under control, until something fails in production. Then engineers open the dashboard and see 3,000 metrics. And suddenly the problem is not missing data. The problem is finding meaning. Because observability doesn't remove uncertainty. It simply moves it from the system into interpretation. When architects think about observability, the first mistake is thinking about tools. Prometheus, Grafana, Datadog. Those are implementations. Systems thinking starts somewhere else. What decision are engineers trying to make during failure? If the answer is unclear, observability will always be chaotic. The purpose of observability is not data. The purpose is diagnosis. When a system fails, engineers need to reconstruct a story. What triggered the behavior? Where the system changed state? Which decision caused the outcome? If telemetry cannot answer those questions, it is just noise. You are no longer running one distributed system. You are running two. The product and the observability platform observing it. Architects should always remember that, because the second system introduces its own complexity. And occasionally, something wonderfully ironic happens. The product system is completely healthy. Users are happy. Everything works. But the observability platform is down, which means engineers cannot prove that the system is healthy. The system works perfectly, but the only system that could confirm that is broken. From a systems thinking perspective, the real design problem is not telemetry volume, it is telemetry alignment. Instead, instrument decision points. Whenever the system makes an important decision, record it. Authorization, routing, retry logic, fallback behavior. Those decisions reveal the structure of the system. The second architectural rule is alignment. Telemetry should follow architectural boundaries. If a service boundary exists, telemetry should reflect it. If a workflow exists, traces should follow it. Observability should mirror architecture. Otherwise, engineers end up debugging metrics instead of systems. The third rule is causality. Good observability answers one question. What caused this state? Not, what signals changed? Those are very different questions. Signals describe symptoms. Causality describes behavior. Another useful mental model is this. Observability is not about collecting data. It is about reducing investigation time. So when architects design telemetry, they should ask a simple question. If production fails at 2 a.m., what information would the engineer need? Design the signals around that moment. And finally, remember this. Observability tools promise visibility. But visibility does not create understanding. Understanding comes from architecture. If the system structure is unclear, observability will only expose that confusion faster. Monitoring asks a simple question. Is the system running? Observability asks a better question. Why did the system behave this way? But systems thinking asks something deeper. What system structure made that behavior inevitable? Because when you understand that, you don't just observe systems, you design them so they are easier to understand. This is systems thinking for architects.